Good afternoon, everybody. This is Mr. Ackerman, and today we are going to talk about vectors. Now, I know that makes some of you twitch with the whole, oh my gosh, vectors, that's from physics. Yes, it is from physics, but guess what? It is a wonderful application for calculus, and the existence of vectors really helps us figure out that, even though a problem may look difficult on its surface, it can actually be simplified down. So a vector is basically just a set of parametric functions that describes something that has both magnitude and direction. And that directionality comes from the fact that we can look at the x variable and the y variable independently, but then we can also look at the pairing of the two variables with respect to this third dimension, t. We can look at how those interact with each other. So when we talk about vectors, you'll notice that there's this strange thing here. We're going to call those echelons. And we're going to use those in place of parentheses because we want to denote that there is movement, basically, of some nature applied to this. Now, I will tell you that the position vector is unique in that, whoops, let me try that one more time. The position vector is unique in that if you use parentheses on that, you'll actually be okay. But if you use parentheses on either the velocity or acceleration vectors, you will be very sad when you lose points if you do not use these echelons. So the relationship between position, velocity, and acceleration is simply that the velocity is not just a derivative of a single function, but rather the derivative of the x and the y variables. In physics, you hopefully learned about this concept called component vectors. And component vectors is basically realizing that a single vector can be made up of the addition of an x and y vector upon each other. So if I look at the x independently, I can look at the rate of change of the position, and I can look at the rate of change of that rate of change for acceleration. Likewise, for the y, we can do the same thing. Other things to take into account, if I find the distance of the velocity vectors, I will get, if I look at the distance of the velocity vectors when they're added together, the x prime squared plus the y prime squared, and take the square root from a Pythagorean theorem aspect, that will give us the speed. That should make sense because I'm squaring these values and adding those together, getting a square root, you're always going to get a positive. And if we take the speed and integrate it, then we're going to go from whatever that speed dimension is to simply a length. And this is a modification of the arc length formula, which we've seen earlier this week. So, vectors, motion along a curve. In the first example, we have a particle moving in the xy plane so that at any time t, the position of the particle is given by x of t equals t cubed plus 4t squared, and y sub t is t to the fourth minus t cubed. And our job is to find the velocity vector when t is equal to 1. So I think about this and I go, what is the relationship between position to velocity? I want to go from like meters to meters per second. That is a rate of change, so we need to take the derivative. So to find the velocity vector, I'm going to call that the v of t. We would need to find the x prime of t, y prime of t. So we simply take the derivative of both of those terms. V sub t can be defined as x prime of t, 3t squared plus 8t, and y prime of t being 4t cubed minus 3t squared. And that would be your velocity vector for any time t. The question specifically says we want to know what is the velocity at t equals 1. So we simply substitute a 1 in for the t to get 11, 1. And I will leave my answer like that. Now, I'm only going to mention this once because it is a notation that you may see later on in college. There is a notation that exists where you could call that 11 I hat plus 1 j hat, or just j hat. The letters turn out to be 3 dimensions, I, j, and k. You don't need to know those. just know that I could theoretically write this, and what this is telling me is in the I direction, which is along the X, we would go 11, and in the J direction, we would go 1. So just don't have to know that too much. It's there, it exists. I'll show you one more time, I suppose, in the next question, and then that will be it. B, find the acceleration vector when t is equal to 2. So we ask, well, how do we find the acceleration vector? Well, we can either take the v of x prime t and the v of y prime t, or if you're not happy with that notation, that's the same exact thing as saying x double prime t, y double prime t. So simply put, we're going to take the derivative of the velocity function, of the velocity vector, which is going to turn out to be 6t plus 8. And the derivative of the y value, y velocity, is going to be 12t squared minus 6t. And the question asks us to find the acceleration when t is equal to 2, which in this particular problem should give us 2036. And again, in that weird I hat, J hat, you can call it 20 I hat plus 36 J hat. But again, you don't really need to have that. Big one is what I am going to circle right here. 2036 written just like that would be fine. Now again, I want to point out, had I used parentheses, not these echelons, you would have gotten this wrong. So make sure that you are being very specific with your notation. You need to make them pokey. Make sure that it is very obvious that I'm not trying to write a parenthesis. All right, let's take a look at the next example. Example 2, a particle moves in the xy plane so that at any time t is greater than or equal to 0, the position of the particle is given by x of t is equal to t squared plus 3t, and y of t is equal t cubed minus 3t squared. And the magnitude of the velocity vector when t is equal to 1. So magnitude, what is that? Well, before we can find the magnitude of the velocity vector, we should probably find the velocity vector. So I state that v of t is going to equal the x prime of t, y prime of t. I like to put this down just so that I know for a fact that I'm doing the question right. I want to show that relationship and show my grader, my teacher, my peers that I understand what I'm attempting to find. So that v of t is going to turn out to be 2t plus 3. And this is going to be 3t squared minus 6t. Go figure. It's good stuff right there. We got that. All right, so that is v of t, and I want to know the magnitude of the velocity when t is equal to 1. So I can say, well, v of 1 is going to equal 5 negative 3. Okay. So where do we go from here? So what I'm looking for is I'm looking for magnitude of the velocity vector. So when I look at this, essentially what I'm imagining is I have got some sort of vector now where the x variable is going over here 5, and this y variable is going to be going down 3. And notice I didn't put a negative 3 because I already showed that it's moving down. And what the question's asking is if I were to find the addition, in fact, let me put that in a slightly different color so we can see it. If I were to try to find the addition of those two vectors, what it would do is it would give me what is called the magnitude or absolute value of v. So this is where absolute value becomes a really weird notation because it no longer means, when you hear about it, we explain it to you at first as the distance from 0, but then we start saying, well, all absolute value does is really, all absolute value does is turn the negative number positive, and that's not the case here. What absolute value really is the distance from a point of origin, in this case from 0, 0. So if I want to find the distance from this position to that position over here, I really need to use my knowledge of triangles to show that the magnitude of v at 1 is going to equal the magnitude of the x variable squared plus the y variable squared. There's 5, there's my 3. Using Pythagorean theorem, 5 squared plus 3 squared should give me the hypotenuse. And that's what we're supposed to do. So when I go through and do that, we get the square root of 25 plus 9, which is the square root of 34. My apologies, I apparently cannot add. And 34 is 2 times 17, which is not particularly useful. So at this point, folks, we are done. So some of this is understanding what we're actually talking about in our math too. Absolute value is no longer positive. Negatives become positives in positive state. It's a distance, so we have to measure that distance. When we talk about velocity vectors, it's understanding that we're not going to have just one derivative, but we're going to have 2 derivatives. And if you can get both of your head wrapped around those things, you've pretty much got all of this. It's done at this point in time. So, a particle moves along the xy plane so that x is equal to the square root of 3 minus 4 cosine t and y is equal to 1 minus 2 sine t, where 0 is less than or equal to t is less than or equal to 2 pi. The path of the particle intersects the x-axis twice. Write an expression that represents the distance traveled by the particle between the 2 x-intercepts. Do not evaluate. Okay, so we're writing an expression for distance. So let's real quick stop and go back to our knowledge of distance from the earlier part. When we said distance, we had said this statement like it's the integral from some a to some b of the absolute value of v sub t dt. And in our problem, we originally said that when we take the absolute value of v of t, it just turns a negative into a positive. Remember now what that statement means. All right? This is actually magnitude, which is the same thing as distance from the origin. So using the same concept, we know what that should be. We know from our previous problem that if we want to know what the magnitude of v is, we really just need to take dx dt at a number. And we need to take dy dt at a number. And we need to use the distance formula. The other thing that we're going to need to do is we're going to need to figure out where on earth these x-intercepts are. Okay? By the way, distance traveled between these points. Another way to think about this is that it's an arc length. So we've got, and we want to know when the x-intercepts are. So, first things first, let's come up with our v of t function. Our v of t vector should be derivative of square root of 3 is nothing. The derivative of negative 4 cosine of t becomes 4 sine of t. And then if we look at y, the derivative of 1 is 0, and the derivative of negative 2 sine of t turns out to be negative 2 cosine t. So now we know what the v of t is. We also need to know where the heck do the x-intercepts happen. And we know that x-intercepts occur when y is equal to 0. So what I'm going to do is I'm going to set my y of t function, which is 1 minus 2 sine of t. I'm going to set that equal to 0. Sine of t has to equal 1/2, and when does sine equal 1/2? It happens at pi over 6, and it also happens at 5 pi over 6. And from this information, you have enough to answer your question, because remember, we're not going to actually evaluate anything. So I want to find the integral from a to b of the absolute value of v of t dt, which in this case is going to be the integral from pi 6 to 5 pi 6. And then we got to come up with that. What is the absolute value or the magnitude of v of t? Well, it's going to be the square root of our x variable squared, 4 sine of t squared, plus our y variable, negative 2 cosine of t squared dt. And if you think about the units, we're going to go from like a meters per second. When we integrate meters per second, we would get meters, which is a distance. On top of that, we've squared two functions, and then we're going to take the square root. We should get a positive value out from that. So that fits all of the expectations we would have for a distance problem. All right, 2 more to go, folks. We got this. Let's see if we can get these done in 4 minutes. A particle moves along the xy plane so that at any time t, the position of the particle is given by x of t is equal to 2t cubed minus 15t squared plus 36t plus 5, and y of t is equal to t cubed minus 3t squared plus 1, where t is greater than or equal to 0. For what value or values of t is the particle at rest? Well, what does that mean at rest? At rest means no movement. And you're all looking at the screen right now going, no kidding, Mr. Ackman, way to be obvious. But more specifically, if there's no movement, we're talking, movement talks about v of t. So what that really means is that my v of t should equal something specific. I should have 0 movement on the x and 0 movement on the y. So really I just need to figure out when does x equal 0, when does y equal 0, and then just match up my answers. So let's find out when x of t is equal to 0. I got to be careful there. I want to know when the v of x of t is equal to 0. There we go. In this case, it happens to be x prime. So we find x prime, 6t squared minus 30t plus 36, set that equal to 0. Factor out a 6, leaving me t squared minus 5t plus 6 equals 0. And we get 6t minus 3t minus 2 is 0. We find out that this is a true statement for t is equal to 2 and 3. We're going to do the same thing for a y vector component. So we want to figure out when y prime is equal to 0. In this case, y prime of t is going to be 3t squared minus 6t plus 1 equals 0. And we now need to factor that. So I know that I'm going to get a 3t and a t. I'm going to get some combinations of... Ooh, wait, nope, that's not going to work. Hold on. I said plus 1. Hopefully some of you were screaming at your screen there for a second. Because that should be 3t squared minus 6t equals 0. Derivative of 1 is back to 0, so don't be a fool like me. So that becomes 3t, t minus 2 is 0. We find out that this y component is at 0 and 2. So the question becomes, when does this have a 0, 0? And this is where students will make a mistake. Students will tell me that the answer is 0, 2, and 3, which is not the case. The answer to this is that the particle is at rest at t equals 2, since v of 2 is equal to 0, 0. Notice that 2 is the number in both of those. At t equals 3, y would not equal 0, and at t equals 0, x would not equal 0. Cool. One more. A particle moves in the xy plane in such a way that its velocity vector is 3t squared minus 4t and 8t cubed plus 5. So a little bit different. Now we've got a velocity vector. If the position vector at t equals 0 is 7, -4, find the position of the particle at t is equal to 1. So again, this is another situation where I want to look at, and this is always going to be the situation. I said it kind of like it's a unique case, but in a vector problem, we never look at the major vector itself. We always look at the simple, smaller pieces. Look, we can only fathom really those single directions. Trying to deal with it all at once is ridiculously difficult. But if I can look at this as an x problem and a y problem, now I have something I can do. See, because I know that x prime of t is 3t squared minus 4t. And the question is telling me to find x of 1. It's also telling me that y prime of t is 8t cubed plus 5, and it's telling me to find the y of 1. So what I'm going to use is a little bit of fundamental theorem of calculus to be able to answer this question, because I know in order to go from x prime to x, I need to integrate. I need to integrate the x prime of t function from some a to b, and if I do that, that gives me the x of b minus the x of a. And in this case, I need to ask myself, well, what values do I know for a and b? And I know that I have data at t equals 0, and I want data at t equals 1. So what this is telling me to do is to integrate from 0 to 1 my x prime of t function, 3t squared minus 4t dt, and that will give me my x of 1 minus my x of 0. And I know what one of those is. I know that at x equals 0, my x value is equal to, t equals 0, my x value equals 7. So I can integrate this problem here. Antiderivative of 3t squared minus 4t is t to the third minus 2t squared. Evaluated from 0 to 1. I can add to that the 7 from over here, and that will give me my x of 1. Or in this case, 1 minus 2 minus 0 plus 7 is x of 1. Negative 1 plus 7 is 6. Now that's half the problem. Because now I need to deal with the y's, and the y problem falls out the same exact way. I know that from some a to b of the y prime of t dt, I'm supposed to get my y of b minus my y of a. Or in this case, again, from 0 to 1, of this time, 8t cubed plus 5 dt, I should get the y of 1 minus the y of 0. And the piece that I know is that when t is equal to 0, the y equals negative 4. So we take an antiderivative. This becomes 2t to the fourth plus 5t evaluated from 0 to 1. And this is going to become a double negative, so that's a plus 4. So minus 4 should give me my y of 1. Or, in this case, 2 plus 5 minus 0 minus 4 is my y of 1. 7 minus 4 is 3. Now, if I leave my problem like this, I did not do the question correct. I have a little bit more that I have to do. I want to give the position of the particle. My answer can either be written as the point 6,3, that is my actual location, or you can write it in vector form, 6,3, which would also be acceptable. And this is one of those situations I was talking about. If you use parentheses or the echelons, you'll get the question right. That's all I have for vectors, folks. As you can see, they're not very different from your particle motion, your parametric problems. It's all of the same exact mathematics. Now it's just we're asking you position, velocity, and acceleration problems where you have to deal with not only just an x variable or a y variable, but now you're just dealing with them as two variable problems. Today, you have got a worksheet to continue. There are several questions, but you do have all of the answers available to you on those questions. Tomorrow, you will have a multiple choice worksheet as well as several of the free responses. And while I did not include the free response answers, as always, I provided both the year, what form it is, and what question it is. The free response questions will all be calculator questions. Even though some of them are question 3, those are older problems, back when we didn't have quite as sophisticated calculators. So that is what you'll be working on tomorrow as well. And the sub will hand you those when the time comes. I hope everything goes well for you. Feel free to send me messages over Schoology or send me messages via email if you have any, as I will be checking them while I sit all by my lonesome while my students are taking tests. And I will try to get back to you as quickly as possible. Have a wonderful day.